Hello everyone, this is Selwa, and today I will be doing a lesson on concavity. What you'll see are a few definitions, some examples, and sample problems. So the mathematical definition of concavity is given that when f is differentiable on an open interval I, the graph of f is concave up on I if f prime is increasing on the interval. The graph of f is concave down on I if f prime is decreasing on the interval. In much simpler terms, concavity is basically determining whether a curve of a graph is face upward or downward in a certain interval. So here's a visual. In the first graph, it's facing upward, therefore it's concave up. And you basically know that because you can see that the graph is curving upwards. In the second graph, it's concave down because, as you can see, the graph is curving downwards. So here's the first example. Determine the concavity of f of x equals x cubed minus 6x squared minus 12x plus 2. The first step in determining the concavity is to find the first derivative. So here is the first derivative. F prime of x equals 3x squared minus 12x minus 12. The second step is very important. You need to find the second derivative. So the second derivative is f double prime of x equals 6x minus 12. In the third step, find where it is undefined or equal to 0. 6x, so we set 6x minus 12 equal to 0. And you get x equals 2. So once you have found that, step 4, create a number line, or in other words, a line graph, like this one. Step 5, plug in a number larger than 2 into the second derivative. It's very important that you plug this number into the second derivative, otherwise finding concavity won't work. So here I plugged in 4 into the second derivative, so 6 times 4 minus 12 gives me a positive number. And next you mark on the graph that it is positive on this interval, like here. And since it's positive, we know that it's concave up. Step 6, plug in a number smaller than 2 into the second derivative. Here I plugged in negative 2, and I get a negative number. And just like the other step, mark on the graph that it is a negative on this interval. And given that it's negative, we know that it's concave down. So here's our second example. Determine the concavity of f of x equals x cubed minus 3x squared minus 6x plus 8. So find the first derivative, which is 3x squared minus 6x minus 6. Find the second derivative. F double prime of x equals 6x minus 6. Here I set that equal to 0, and I get x equals 1. Now, I plug in a number greater than 1 into the second derivative, and I get a positive number. And I get a number smaller than 1 and plug that into the second derivative, and I get a negative number. Now, I put that into the line graph over here and see that it is positive on this interval, therefore it is concave up, and that is negative on this interval, therefore it's concave down. Here are some sample problems that you might want to go over just for review and practice. Thank you for watching this video, and feel free to watch again if you didn't get it the first time. Thank you.